Hello everyone, welcome to this video. This is part 6 of differential equation and already 5 part covered. If you want, you can watch from the description box, is given, right? So in this part, we want to discuss actually the first order first degree differential equation solution. Actually, in the 4 methods already discussed for the first order first degree uh, differential equation, ordinary differential equation. In this part we want to apply this solution of the differential equation in various purpose of the physics problem, right? The purpose mainly we want to discuss about the electrical circuit mainly the LCR circuit, inductor, a capacitor, a resistance. In this circuit, LCR circuit, actually wants to discuss. We got the this type of differential equation, first order first degree differential equation. Mechanics, less like different force, resistive force, like that. um, the force sometimes proportional to V, like that. Okay, so this is dv dt. In this case, this mechanical, where we got the first order first degree differential equation. Heat conduction, suppose this is a hot body and cylindrical body, the heat radiated. This is temperature radiation, obviously proportional to temperature difference, right? This is surroundings temperature T0 or within temperature T. This difference will be the radiative rate, temperature radiation rate will be proportional to temperature difference within the body and the outside. And in case of spring, in case of spring, the spring is force is proportional to minus kx. So in this phenomena there is any other purpose also. So here we discuss about these 4 types of physical phenomena where we got the first order first degree differential equation and how they can be solved, we can discuss, right? Actually, we follow up the mathematical methods by H.K. Dass books. H.K. Dass. These books we follow, and this is the exercise number 3.9 of that book. Here the question says that the a coil having a resistance of 15 ohm, the resistance is given is 15 ohm and it inductance of 10 Henry. The inductance is 10 Henry, is connected to a 90 voltage supply is connected. Determine the value of current after 2 seconds. After 2 seconds, what will be the current in this circuit? Okay, are you clear about the question? Differential equation of this circuit will be L di dt plus IR equals to E. This is the inductance voltage, inductive voltage L di dt, and this is the resistive voltage. This will be equal to E by the Kirchhoff voltage law, KVL, Kirchhoff's voltage law, Kirchhoff's voltage law, you can say. So you this rearrange this, you will be get this is the first order linear differential equation. This is the first order linear differential equation, and to solve this type of linear equation you need to find out integrating factor, which is integration p dx, right? So here p is the L by R, so you get the integrating factor and just multiply this integrating factor and rearrange. Then this will give you the integrating factor into y. Here y is I, and if you integrate this one you will get this type of equation. And if you put the initial condition that t equal to 0, I equal to 0, you will get the constant, and they put this value and then put the given value E, R, etc., etc. At the time t equal to 0 2, you will get this answer. Take the screenshot and you can check it with your answer, right? Next question, a resistance of 70 ohm and inductance this Henry connected in the series. The similar type question, determine the expression of the current of the function of t. So in the similar fashion we will be get the same expression from the previous and put the given value, you will be get the answer, right? Next, there is a circuit consists of resistance and the capacitor, condenser. Difference between condenser and capacitor is this condenser one side will be earth, that's why this known as condenser. Okay, so this is farad connected in the EMF E and Q with the voltage. So you can see voltage across the resistance and voltage across the capacitor will be equal to total EMF, and the voltage across the IR, and this is Q by C. So they will be get this answer, right. Next, here, so that the current will be this during the discharge of condenser of Q charge through the resistance. So the similar circuit, and since this is a discharge, there is no voltage supply, that's in the right hand side will be 0, and this is QYC and this is IR, and just take the integrating factor, multiply this integrating factor, you will get this answer, and put this initial condition that at t equal to 0, that is the initial, this is the full charge, after that they will be decayed. So at this initial, this is full charge, if you put this value, you will be get this equation, and this minus signify the further decay. Here there is no minus, here there is no minus, actually they during says already decay, or you can put here minus for decay, you will be get the positive answer. If you put here minus for decay, you will be get plus. Okay, I think clear. Next question, a condenser of capacitor C with voltage V0 discharged through a resistance ohm, and Q is this. So these are the given, and I is given dq dt. So this is the equation, and after that if you put the previous problem, you will be get the similar answer, and this is got from the previous problem, just like previously we draw same manner, just same manner you will be get this equation. After that, if you wants to find out the current dq dt, just derivative with respect to t, you will be get the current, and the voltage will be IR, so multiply, you will be get this answer. Clear. Next, solve this differential equation. So this differential equation can be rearranged along this, and this is the first linear differential equation. You will get the integrating factor, multiplying this integrating factor, and solve this, you will be get the answer. There, this from is actually e to the power bx cos omega t, like that. This integration done here separately. You can also done this integration separately, and just put this value, you will get this answer. There the constant is not obtained, actually if there is initial condition given, then we can calculate condition constant value, but here there is no initial condition given, we cannot find out this constant value. Here we write because they know the initial condition. Okay, so this is the solution. You can check this, just um, do yourself this calculation, this long calculation. Okay, next, a circuit consists of resistance R ohm and inductance L, resistance and L inductance connect in the generator. This is the voltage source. Here the voltage source is changeable, right. Find the current of this circuit. Initial condition is given here. So this is the same manner, you will get the left hand side, but in the right hand side you will get this expression, and this expression also can be calculated by this formula, just this formula, and take this constant here, you can get this answer. This is a long process, you just take screenshot and verify yourself. Next, and inductance of 2 Henry and resistance 2 ohm are connected in series of this and this. So this is the same type question, so you just use the previous formula we got, you get the answer, and the similar you will be get this integration. Now this is the same integration, you just solve, you will be get this answer like that. Okay, next, sorry, uh, a 20 ohm resistor connected, this is a capacitance RC, this is R, this is C, and farad EMF is given like that, the maximum voltage will be that coulomb. So the equation will be like that by KVL, voltage across capacitor, voltage across resistance will be total voltage. Just separate out these two, you will be get integrating factor. After integrating factor, you just integration, will be get this type of answer. Clear. Just then put the initial condition, we get this answer like that. I think there is any error or mistake, you can just check. Next question, when a resistor R and capacitor C connected in the series, the EMF will be, equation will be like that. Where is this? To find the current at t equal to 1 second. So you need to find the current from this equation. So take out this equation and rearrange them. We get this differential equation and solve this differential equation with this is the common integration or already calculated in the previous one. So you get the answer. Next is the application in the mechanics, because exercise 3.10. Here says a moving body is opposed by a force proportional to the displacement. That is, force is proportional to the displacement, opposite is denoted by negative sign, and resistance proportional to the square of velocity. This is square of velocity. So k1, k2 are constant. So if you change this force dv dt, dv dt can be changed as dv dx, and to dx dt, dx dt is v, dx dt is v. So this is the equation, m is divided here, so you will get like that. Now if you take v square equals to z, you will be get this derivative and put in this equation. Sorry, what happened? Oh, right. Sorry, right. So if you put this value, integrating factor like that, and after putting this value, this is becomes a linear differential equation, and then you get then calculate the integrating factor. After calculating the integrating factor, the same manner you will be get the answer. Here the constant will be like that, put this value. Okay, so do yourself and then check this one. Next, assuming that the resistance to the movement of ship through the water is like that. So resistance is the force equal to like that, and constant, write down the differential equation and prove the time of the speed through one half the original velocity u. So if you just integrate, separate out, integrate, and put this initial condition that at t equal to 0 the velocity will be u, so p will be constant value, and we want to find out the time at v equal to u. So if you put this value, you will get this answer. Okay, next, a ball is dropped from a height 6 meter and rebounds infinitely often, assuming that the rebound 80% of the distance of its fall. If you from 6 meter, will be up into 80% of 6. So after that, if you the same manner will we get a infinite series, put this, will get answer like that. Next, heat conduction. Radium decompose at the rate proportional to the amount present. If 5% of the original amount disappear in 50 years, how much will remain in the after 100 year? Okay, so the rate decrease, that is the minus dn dt proportional to present. So just separate out and integrate, you will be get that at t equal to 0 the original value will be equal to n0, put this, you will be get this in constant. After that 5% disappear, that is 95% return. So if you put, you will be get the value of actual lambda we retain in this from, and after t equal to 0 n will be n0, it will be this. So this can be written as like that. If you put this value, you will get this answer. Okay, next, if a thermometer taken outdoor where the temperature is 0 degree, so outdoor temperature is 0 degree and the inside temperature is 21 degree, it drops 10 degree in 1 minute. If time equal to 1 minute, it drop 10 degree, so remaining is 11 degree. How long removal will be reading the 5 degree? What is the time and in which the temperature will be 5 degree centigrade? So this is the rate Newton's Cooling's law actually. dt, that is capital T is temperature, small t is time. The rate of cooling is proportional to temperature difference between outside and surroundings, inside and surroundings. Okay, so this will be like that. If you integrate and put the condition that at equal to 0 when is inside temperature was 21 degree, if you put this will the equation and then put this condition, you will be get the value, and after that put temperature equals to 5, they will get the answer. Next, in one dimension steady in one dimension steady conduction of hollow cylinder of constant thermal conductivity K in this region, temperature Tr at a distance, this is a hollow cylinder, and temperature at r distance is Tr, temperature at r distance is Tr. Okay, where given is, so if you integrate, this will be constant, and then if you again integrate, there is two constant can be calculated if given the two condition that r equals to a, t equals to T1, and r equals to 2, temperature will be T2. Put this value, these two equation, and just solve this one equation, you will get T1 and a K1 constant and K2 constant. These two constant K1 and K2 put in this equation, you will be get the answer like that, where this R1 equals to A and R2 equals to B. Check yourself. Next, this is a spring. A particle of mass m attached on one light spring of modulus lambda, that is a spring, and this particle is attached in the, prove that the velocity of the particle when transverse distance a, when it transverse a distance a, the velocity will be like that. So the equation of motion will be, this is force, so this is mg minus lambda x, and this can be written as dv dx into dx dt is v. So this like that, and just integrate these two, if you get this is v square by 2 and this is gx minus lambda x square by 2m plus constant, and put this initial condition, that is as x equal to 0, then v equal to 0, then you get the constant value is 0. So if you get this answer, and when put x equal to a, traverse a distance a, so if you put x equal to a, will get this answer. Okay, so I think clear. If there is any doubt, you must comment in the comment section. This is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you will get the previous videos which already uploaded. Share this video to your friends so that he or she also get benefit. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription, and press the bell icon to get the notification of upcoming videos. So take care, we will meet in the next video as soon as possible. Thank you.